Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is on MCQ and the question is in front of you. I request everyone please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. I believe you have tried, so let's start. Now the question, rank the following alkene in order of increasing lambda max wavelength. These three compounds are given. So first question, what is the relationship between wavelength and molecules? Now actually if you say wavelength of an electromagnetic radiation, and what is its relationship with energy? If you look at energy, it is equal to E is equal to h into nu. H is Planck constant, nu is the frequency of the radiation. And now if I say this nu could be replaced by c by lambda. What is c? C is velocity of light and lambda is the wavelength. So from here I can conclude E is proportional to 1 by lambda, means inversely proportional. Now what is this? E is the energy associated with this electromagnetic radiation or energy gap, and lambda is the wavelength. Now if you look at higher the conjugation among alkenes, lower will be the homo-LUMO gap, and obviously it will reflect higher value of lambda. That was our question. Now if you look at this molecule, now there will be question how energy is related to this. For that purpose, look at here. If you look at this is your butadiene, it is actually a conjugated alkene, and if you want to understand its property, then let's plot it against energy. Now if you look at these two double bonds or pi bonds, they are homo of isolated alkene. Homo means highest occupied molecular orbital, and this filled one is called LUMO, lowest unoccupied molecular orbital. Now so since they are in conjugation, that's why what happened, the two homo of these two double bonds, they undergo conjugation. So what it result? It result one lower energy pi 1 and relatively higher energy filled orbital pi 2. By the way, this is actually the homo of new molecular orbital because it is occupied. Now similarly, these two LUMO overlap and produce a lower LUMO psi 3 star. Now if you look at, because of this conjugation, homo energy rises and LUMO energy comes down. So for that purpose, what happens? So the homo-LUMO energy gap decreases. So if homo-LUMO energy gap decreases, the electronic transition from here to here could be achieved using higher wavelength, I mean lower energy electromagnetic radiation. So this is actually the concept. Now what can I say? More the conjugation, lesser the energy gap, bigger the wavelength. So this is the conclusion from here. Now if you look at here in this molecule, if I say, then you can clearly see, sir, 1 double bond, 2 double bond, 3 in conjugation, means further conjugation you can, that time you may expect, sir, there will be a homo-LUMO energy gap is even smaller, so lambda will be the highest here. Okay. Second case, here if you look at 1 and 2, no conjugation because sp3 hybridized carbon atoms are present. Now if you look at here 1 and 2, they are in conjugation. So in which case conjugation is maximum here? So conjugation maximum means obviously lambda value will be maximum, energy gap minimum. So option 1 will be the maximum. Now which option? Okay, option D. Now look at next is 3. Why? Because here also one conjugation exists, so the energy gap will be moderate, lambda will be moderate, and in this case which option number 2, there is no conjugation, the gap is higher, obviously lesser lambda max. So this option D is the right answer. Now if you get this question less than 30 seconds, how could you solve? First you need to remember, student, higher the conjugation, lower the energy gap, and obviously higher the wavelength. So if you look at, so it is the maximum wavelength or minimum energy, which option? Only one. So in this way you can get the right answer, you don't need to think much also, it's very easy options. Okay, so this way you can easily get the right answer. Now in conclusion, what we have learned today, that pi bonds of an alkene can further undergo conjugation by parallel or sidewise overlap of the pi bonds, and higher the conjugation among the double bonds, lower will be the homo-LUMO energy gap, and this will result higher value of lambda max. Next, highly conjugated systems are generally colored in nature. Why? Because the energy gap comes down, and that's why they can absorb visible light as well as they can emit that. So that's why they look colored. So this is the very interesting learning. So this is the overall discussion. Thanks for watching. See you in my next video. Bye bye.